In this lecture, we will going to talk about the half adder and full adder.
So generally when we are using a combination circuit design, we have to keep some parameters, okay, into our mind, that what is the input and what is the output. So what we have to do, we have to generally identify the input and out. Then what we can do, we have to construct the truth table of it. Then we will going to construct the Boolean or logic expression. So we can construct the Boolean algebra expression. I'm writing short form, either in the SOP or you can write in the POS. Then what you will going to do, you will going to minimize that logic expression. Whatever the logic function you have got, you will going to minimize the logic function. And finally what you will going to do, you will going to construct the logic circuit. You got this point? So just take an example of a arithmetic circuit. So the first arithmetic circuit we will going to talk about is the half adder. So the first thing which we will going to discuss is about the half adder in it. So let's say we will going to construct the half adder first. So half adder, what we have got in half adder? You have done the adder. So you have seen in the adder what you are doing, you are adding two numbers. So when you are adding two numbers, what you can get a sum or you can get a carry. So I have an input, let's say input A and input B. So I can have a two output. One can be my sum and one can be my carry. And if I write a truth table of this, so I can write a truth table like this: A, B, sum, and then carry. Okay, so let's say 0, 1, 0, 1, 0, 0, 1, 1. So if I talk about the what are the 0 plus 0, sum will be your 0. What will be the carry? Carry will be 0. What is 0 plus 1? 1. Carry will be 0. Okay. What is 1 plus 0? 1. Carry will be 0. Now what is 1 plus 1? 1 plus 1 is 10. 10 means you will going to store one element 0. Okay. So 1 plus 1 will going to give you 0 and your carry will be 1. The same you are doing like this. Yeah, everybody agree? So if I try to draw this with the help of a K map, so I will write A here, B here. So this is 0, 1, 0, 1, and this will be your, what is this? If I will take here sum, okay, and then I will going to draw for the carry, K map. I will going to draw a K map for both of these. 0, 1, B, A, 0, 1. Okay. Now what I will going to do, I will going to put these values. Where is sum is present? At 0, 1, 2, 3. So where it is present? At 0 nothing is present. 1, 2. And if I talk about the carry, so carry we are getting only at 0, 1, 2, 3. That means I am getting here only. So if I write the answer of it, what will be the answer of this? A bar B, and what will be the answer of this? A B bar. So my sum will be equal to A bar B plus A B bar, and what this is equal to A XOR B. And if I write this, if I take this one, what will be my carry? This will be my AB. So my carry will be equal to AB only. So what I can do, I can draw a circuit for this, that I have got A, I have got a B, and if I do the XOR of this, okay, so I will going to get the sum, and when I will going to multiply it, I will going to get a carry. You are getting it? And what this completely look like? This completely will be your half adder circuit. So do you think there is any feedback here? Is anything coming from sum to A or from carry to A or B? No. So you can see there is no feedback. Is there any memory? Do we are storing any A any sum value or we are storing any carry value? No, we have not got any memory also. So this is known as your combination circuit. Similarly, when we go for the full adder, let me draw for the full adder now. In full adder, what we have got? We have got A, B, and let's say C. Okay, then we have 0, 1, 0, 1, 0, 1, 0, 1. Then we have got 0, 0, 1, 1, 0, 0, 1, 1. Then we have got 0, 0, 0, 0, 1, 1, 1, 1. So what will be my sum? Okay, so I will be getting my sum here and I will be getting my carry here. So can you quickly tell me what answer I will be getting for this? 0, 0, 0. Anything I will be getting? No. I will be getting the 0, 0. Sum 1, 0, 1, 0. 1, 0 plus 1, 1, 1 plus 1, 10. 10 means 0, 1. Is it correct? And 1, 0, 0, 1, 0, 0, 1, 0, 1, then 1, 1. Everybody got this table? Now what we will do? We will going to design the K map of it. Okay, so this is A, B, C. That means 3 variable K map. So let's say this is my A, B, C. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Where my 1 is present? My 1 is present at 0, 1, 2, 3, 4, 5, 6, 7. So my 1 is present at which point? 1, 2, 4, 7. Okay. So you will going to find that if you find out the solution for this, the sum will going to come. For this we will get A, B bar, C bar. For this we will going to get A bar, B bar, C. For this we will going to get A, B, C. And for this we will going to get A bar, B, C bar. And this is nothing but your A XOR B XOR. This is your A XOR B XOR C. If I draw for the carry, so where I am getting 0, 1, 2, 3, 4, 5, 6, 7. So 3. Where is my 3? Here. 3, 4, 5, 6, 7. This is my A, B, C. So what I will be getting? I will be getting like this. This pairing, and this pairing. Do you agree? So what will be my answer? My answer of a carry will be 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. If I am talking about this one, so my answer will be AB, BC and AC. This is the answer you are getting. You are getting this answer. So in this way you can design half adder, full adder, and you can design this circuit. You can design this circuit. So we have designed half adder and full adder, and when you will going to design a circuit of it, you will going to see again there will be no feedback part coming, no memory is coming in it. So thank you everyone. I hope you enjoy this lecture.